We've learned about simplifying simple radical expressions. When there's a radical in the denominator of a fraction, we can rationalize the denominator by multiplying the top and bottom of the expression by that radical. We want to remind ourselves that we're not allowed to leave a radical in the denominator of a fraction. And so we'll rationalize the denominator by first simplifying the radical that's in the denominator of the fraction, and then multiplying the top and bottom of the expression by an expression that's equivalent to 1, and then simplifying numerator and denominator. We'll also find out that we can simplify some more complicated radical expressions in fractions this way. So let's go back and take a look at a couple of examples. For instance, 3 over the square root of 5. If I multiply the denominator, square root 5 times square root 5, remember that's square root of 25, in the numerator, 3 times the square root of 5. Well, the square root of 25, remember, is just 5. That's what we call rationalizing the denominator. When I multiply square root 5 times square root 5, I get 5. The numerator is 3 times the square root of 5. Now look at these. There's no common factors outside the radical. I can't simplify that further. Similarly, 7 over square root 3. I'm going to multiply the top and bottom of this by the same thing, so this is equal to 1. So I get 7 times the square root of 3. Square root 3 times square root 3, well, that's just 3. Now I can't simplify this 3 here and the 3 that's inside the radical. I have to leave those that way. 10 over the square root of 8. Now square root of 8, remember, simplifies down to 2 times the square root of 2. I can go ahead and cancel my 10 divided by 2 here. I get 5. 2 divided by 2 is 1. 5 over the square root of 2. Now I can rationalize by multiplying top and bottom by square root of 2. So 5 times the square root of 2 over 2. So we simplified first the square root of 8. We divided the top and bottom by a common factor, and then went ahead and simplified the rest of the way. Let's look at one that's a little bit more challenging. Square root of 6 in the denominator. I'm going to multiply the top and bottom by square root 6. Now at the denominator, I can see that square root 6 times square root 6 is going to be just 6. Now here, this is the distributive property. So I have 6 inside the radical times 2. So 2 times the square root of 6 minus square root 6 times square root 6, that's 6. Again, I would need to be able to divide here, here, and here by 6. I can't do that. I can divide them all by 2, though. So I divide by 2 here, I get square root 6. Divide by 2 here, I get 3. Divide by 2 here, I get 3. Let's look at what happens when I have a radical in the denominator in which the radicand is a variable. So square root x times square root x, that's just x. 4 times the square root of x in the numerator. And again, because this x is inside a radical, I cannot simplify that. I can't divide out that x with this x that's in the denominator. Does this work if I'm using, say for instance, a variable with a coefficient inside the radicand? Well, sure. Square root 3x times square root 3x, that's going to be 3x. In my numerator, 15 times the square root of 3x. Now let's see if there's any common factors here. 15 and 3 both divide by 3. 15 divided by 3 is 5 times the square root of 3x. 3 divided by 3 is 1, so I have x remaining. That simplifies that way. Now here, do I need to multiply by the 5 that's outside the radical? I don't. I just want to go ahead and see if I can rationalize the square root of 2y. So I'm going to multiply by square root of 2y in the denominator and in the numerator. So 4 times the square root of 2y in the denominator, 5, and then the radicand, when I square it, comes outside of the radical. So I can see here that I have a common factor of 2. So 2 times square root 2y over 5y. Here's one that's a little bit more challenging. The radical contains an expression x minus 2. When I square a radical, the radical sign and the squaring undo each other, and I'm left with just the radicand, x minus 2. My numerator, 6 times that radical expression, 6 minus 2, and that's all I can do with this expression. I have to leave it that way. There's nothing here where I have common factors that I'm able to eliminate. Let's look at some more complicated expressions that contain radicals in the denominator. We're going to go ahead and eliminate those by using a tactic called multiplying by a conjugate. When we say conjugate, we have two terms that have opposite signs. You've already seen this when we did difference of two squares. X plus 2 times x minus 2 gave x squared minus 4. Those middle terms sum to 0. We're going to use that same process. So 2 plus 3 times 2 minus 3. X plus y times x minus y. 3 plus square root of 2, 3 minus square root of 2. So let's see what happens if I take a conjugate and multiply it times an expression. 3 minus square root of 5. Its conjugate is going to be those same two terms, 3 and square root of 5, but this time added. So 3 times 3 is 9. 3 times square root of 5. And then I have a 3 times the negative square root of 5. So that's minus 3 times square root of 5. And then square root of 5 times square root of 5 is just 5. Well, look what happens here. 3 times square root of 5 minus 3 times square root of 5. That's just 0. I have 9 plus 0 minus 5. This expression, when I multiplied it out, was equal to 4. You'll notice that no longer is there a radical in that expression. 2 minus the square root of x is the conjugate of 2 plus square root of x. So 4 minus 2 square root x plus 2 square root x minus x. These go to 0. I have 4 minus x as the product when I multiply these two conjugates. One more. X times x, x squared, plus x times the square root of 7 minus x times the square root of 7, and then minus 7. These two sum to 0. X squared minus 7. So what can we do with this now? It turns out that now that we see that by using the conjugate, we can eliminate radicals. If I multiply top and bottom of an expression by a conjugate, I can use that to rationalize the denominator. So I have x plus square root 3. Its conjugate is going to be those same two terms with the opposite sign. So I'm going to multiply top and bottom by x minus square root 3. So 2 times x is 2x. 2 times square root 3. In the denominator now, x times x, x squared, minus x times square root 3, plus x times square root 3, and then 3 times 3. So my denominator is x squared minus 3. My numerator, 2x minus 2 times square root 3. And that's as far as I can go with that. I can't simplify that any farther. Let's try another. 7 minus square root x, its conjugate is going to be 7 plus square root x. So let's multiply in the numerator. 5 times 7 is 35, plus 5 times the square root of x, plus 7 times the square root of x, and then square root x times the square root of x, that's just x. My denominator, 7 times 7, 49, plus 7 square root x, minus 7 square root x, and then I have minus x. So let's see how this simplifies. X plus 35 plus 12 times the square root of x. In the denominator, I have negative x plus 49. I'm going to write that as 49 minus x. And one last one. X squared times x, x to the third, minus x squared times square root 5, minus 5x minus 5. My denominator, x times x, x squared, minus 5 square root x, plus 5 square root x, and then minus 5. So my denominator, x squared minus 5, my numerator, x to the third, minus 5x, minus x squared times square root 5, minus 5. I think if we were absolutely correct, we change these around by standard form. We go in descending order of exponents. But regardless, there's no way possible to simplify this any further. And I no longer have a radical in the denominator of my fraction. So that was my goal, rationalize the denominator.